Wow, they got it zoomed in for once right onto Old Faithful. They usually don't zoom in this much. Oh, yeah, right when I say it, they zoom out. That's kind of funny. Okay, howdy there once again, YouTube. My name is Ben Ferraiuolo. Please like, share, subscribe if you like my work. And also please visit my website, https://monitorsize.weebly.com for information on earthquake statistics, seismic image archives for a few volcanoes, my Seismo blog, how to download seismic data, analyze spectrograms, seismograms, spectral plots, helicorders, and much more. This is the fourth monthly volcano report. This is for the month of October 2018. I will also be doing yearly reports as well. The earthquake counts that I state are taken directly from the United States Geological Survey and their partners, and are only earthquakes reported, not earthquakes recorded. In regards to earthquake counts, it is likely the majority of the time that the reported earthquake total for a given location and time period, especially during a swarm, is lower than the actual count of earthquakes. In some cases, sometimes drastically lower. This has to do with a multitude of factors, including inability to locate, lack of instruments, and other reasons that, to be honest, make no sense to me. It is my goal to eventually major in seismology and also study volcanology, but I do believe I am properly equipped to give you guys a heads up if anything concerning may occur at volcanoes throughout the United States. Remember, most earthquake swarms of volcanoes do not lead to eruptions, but almost every eruption is preceded by a swarm. That is why swarms should always be monitored closely at volcanoes. So the volcanoes I will be doing monthly and yearly updates on will be Yellowstone Supervolcano in Wyoming, Long Valley Supervolcano in California, Newberry Caldera in Oregon, Mount Rainier and Mount St Helens in Washington, Mount Hood in Oregon, and Mount Shasta and Lassen Peak in California. Glacier Peak, a volcano that is about 50 miles or so east of me, the one I live closest to, has no monitoring instruments except for one sometimes faulty seismograph. So really, it could be showing signs of an eruption right now and we really would not even know. The Pacific Northwest Seismic Network is putting new instruments there soon, hopefully, and Glacier Peak will be added to the updates once monitor installation has been completed. In this video and other updates, we will look at earthquake and deformation counts. The time period of the earthquake counts for this video is from 0 UTC, October 1st, 2018, to 2359 UTC, October 31st, 2018, and magnitudes are always going to be negative 0.5 and above. Yes, earthquakes can occur at negative magnitudes, but they do require sensitive seismographs to accurately locate. I like to call these negative earthquakes micro-minis. Every month's update will be uploaded a few days after the month in question is ended. Also, please go visit Scott's new channel called the NW Geology Guy, which of course would be the Northwest Geology Guy. I will post a link to his channel in the description box below. It is a brand new channel and it will be very exciting to see how it grows. As always, let's start with Yellowstone. Here we are at Yellowstone Supervolcano in Wyoming. You can see earthquake right here, a few quarry blasts here, an earthquake here, earthquake spread around this area, a little swarming around Maple Creek, earthquake spread around the rest of the caldera with a few down towards the south towards the Tetons. So there have been 88 reported earthquake events for the month of October 2018. There has been some slight swarming near the Maple Creek area, with other random quakes spread out throughout the area, but no major earthquake swarms occurred during the whole month. Also, a magnitude 2.7 earthquake right here hit the peninsula located here at Yellowstone Lake. This is a very peculiar location for an earthquake. Although not shown on this map, there have been some interesting medium-sized swarms up north in Montana, just a little bit north of Bozeman, I believe. The hydrothermal changes that were taking place on Geyser Hill and the Upper Geyser Basin has slowed down significantly. Whether this is just a lull in the activity or a complete end is currently unknown. We will keep a close eye on it. Now remember, when magma attempts to pierce the crust above it, forming an event known as magma intrusion, also known as magma injection, the heat and pressure against the rock surrounding it will cause the rock to destabilize, causing, at the very least, a microquake swarm. I mean, just think about magma, guys. Do you think it's cold? No, it's pretty hot and very powerful. Again and again I say magma intrusion very, 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 very rarely occurs with little to no earthquakes. It always causes an earthquake swarm because of the intense heat, pressure, and gas buildup. Also, the current Steamboat eruption count for 2018, at the time of recording this, is 25 times. In order to beat the record of 29 eruptions in 1964, it must erupt 5 more times before the year is over. So this definitely is one of the most active years for Steamboat Geyser that we have seen for a long time. Here we are at the Steamboat counter at volcanoes.usgs.gov/volcano/Yellowstone. As you can see, Steamboat geyser erupted 6 times in September and 4 times in October. Now, hydrothermal activity does seem to be slightly increasing along with Steamboat eruptions, but seismicity remains far lower than what we would expect to see during these changes. Either that means that these changes are very short-lived and they'll only go on for the next few months or so, or that means the strongest seismic events are still approaching. Please help me monitor this area accurately. Real quick, here's the seismogram spectrogram spectral plot of the 24th Steamboat eruption of 2018. This occurred at 1:29 UTC, October 24th, 2018, which also works out to 7:29 p.m. Mountain Time, October 23rd, 2018, because UTC is ahead of the time zones here in the United States. But if you go to the Steamboat counter at volcanoes.usgs.gov/volcanoes/Yellowstone, you will see they state that it occurred at 9:29 p.m. Mountain Time, but someone made a mistake, since 1:29 UTC, which we obviously see it started at 1:29 UTC, is 7:29 p.m. Mountain Time. At least right now, until Daylight Savings Time ends. When Daylight Savings Time does end, which I believe is November 4th, then 1:29 UTC will then become 6:29 p.m. Mountain Time. Now here's the monthly update for Yellowstone provided by the Yellowstone Volcano Observatory. Now I usually don't pay too much attention to these, unless they're for other volcanoes in like Alaska or Hawaii. But for Yellowstone, I usually don't pay too much attention to these, since I monitor the area very closely myself. But I do check it every month just to see if there's something that I missed, just in case. It's always good to have all your bases covered. I am showing you this because I found something very peculiar. Now, notice here how it says the largest event was a micro-earthquake of magnitude 2.7 located about 14 miles east-southeast of West Thumb, Wyoming on October 21st at 3:06 p.m. Mountain Time. Now, I find that very, very interesting, since I have always known that microquakes are usually magnitude 2.0 and below. So why would they call this 2.7 earthquake a micro-earthquake when it is well known anything below a 2.0 is labeled a microquake? You can even see a definition right here for the term micro-earthquake. So the 2.7, which I will show in just a second, should not be labeled as a micro-earthquake. I am confused as to why they labeled a magnitude 2.7 a micro-earthquake. It is not a micro-earthquake. Those are magnitude 2.0 and below. This is not. This is 2.7. So, I don't know. Again, for the Yellowstone Supervolcanic Complex, there were 88 earthquakes in the month of October. Now, I have spread out the perimeter here, so you can see a few extra earthquakes down the Tetons and a few extra earthquakes over here into, what is that, Montana or Idaho? I think that's Montana. So there seems to have been 2 magnitude 2.7 earthquakes. For the sake of time, I will show the most recent largest earthquake, which was a magnitude 2.7 at 10.1 kilometers in depth on October 21st, 2018 at 21:07 UTC. It occurred in a very, very odd location where I personally have never seen one occur before. Now, real quick, let me open up a new tab real fast. This is new. Okay. One person reported feeling it. One person. Let's see. Does it show the map? Where they feel it. I don't know where they said they felt it. I don't know. Where is it? Let's show them. Come on. All the way out here. They felt the 2.7. Okay. So they call it a micro-earthquake. They call this 2.7 a micro-earthquake when really someone felt it all the way out here in Idaho Falls. Really. Okay, yeah. You can't feel micro-earthquakes that far away, guys. Definitely not a micro-earthquake. For your convenience, here are the seismogram spectrogram spectral plots for the largest earthquake to occur at Yellowstone within the month of October, which actually occurred just a couple miles south of station YTP, the station I gathered data from to create these plots in the southern section of Yellowstone Lake. Notice, even though this station is only a couple miles, if that, from the epicenter, is very close, the dominant frequencies are below 15 Hertz. This is a very peculiar earthquake, guys. Look at how low the frequencies are for how close this station was. It's definitely not a high-frequency earthquake. I don't think you can label this high frequency, but I don't think you can label it a low-frequency earthquake either. So we do see dominant frequencies below 15 Hertz, making this, I'm going to say, a mid-frequency earthquake. You can see, thanks to the spectral plot, that the strongest frequencies are below 5 Hertz. Notice that? The strongest frequencies are below 5 Hertz. You can see that as well on the spectrogram. Also, please note the length of time for this earthquake from start to finish was about 26 seconds or so. This earthquake was for sure an odd event. Now, this event was so cool and weird that I even had to write my own article about it on my website. Notice magnitude 2.7 at Yellowstone Lake on October 21st. You can find this article by clicking my website link in the description box below and going to my Seismo blog. You can see there was an earthquake. Let me go down, let me show you real quick. Blah, 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 blah. Oh, I should show you on the helicorder. You can see there was an earthquake that occurred just after the initial 2.7, and it occurred 1 minute and 10 seconds later, and seemed to be almost exactly the same type of earthquake. So please come to my website and check it out. I even have other articles about other activity at Yellowstone during the month of October. So just come check that out if you want. Here are the GPS deformation charts for Yellowstone National Park and Caldera. Let's start with LKWY, which is at the northern tip of Yellowstone Lake. Here is vertical, uplift subsidence. Oh, let me move this over real quick. There we go. So this is vertical, uplift subsidence. The top two charts are always horizontal deformation charts, with east showing east-west deformation, and north showing north-south deformation. The one you focus on usually is the one that says up, which detects uplift or subsidence, inflation, deflation. Subsidence was occurring, notice that? But it seems we are possibly about to see another period of uplift, possibly. It is unknown whether this is a lull in subsidence or the start of another round of inflation, as we have seen twice since 2005. Also, looking at the middle chart, which shows north-south horizontal deformation, the ground seems to be starting to head north. Notice it's starting to head upwards, right? So it's starting to head north. No change is really seen on the east-west horizontal deformation chart, which is on the top right here, for vertical deformation. From the top of the chart to the bottom of the chart, we see a total of 0.3 meters. Let's go back. Let's go over here. We just clicked on LKWY. Let's click on of.2 right here. Here's the GPS deformation chart for the Upper Geyser Basin near where Old Faithful resides. We see sort of the same pattern here as well. Here is vertical deformation. It actually seems like this station is detecting more subsidence than at Yellowstone Lake. Look at the most recent data right there. We also notice the north-south horizontal deformation chart shown right here is now showing that the ground may be starting to move towards the north, just like we saw on the deformation charts for LKWY. East-west deformation seems to not be changing too much. The vertical deformation chart shows a total of 0.25 meters from bottom to top. Let's go back and let's go up here, northeast of Lake Yellowstone, Yellowstone Lake, WLWY. And here are the deformation charts for WLWY, which resides just a few miles northeast of LKWY at Yellowstone Lake. Again, this chart is uplift subsidence, in other words, vertical. It seems subsidence has slightly started again. Look at the most recent data, guys. It seems to be starting to go down once again. Now, why is LKWY not showing as much subsidence as of.2 in the Upper Geyser Basin and WLWY here, northeast of Yellowstone Lake? Could there be another swarm approaching for Yellowstone Lake? Maybe there's a little bulging underground? I don't know. We'll keep a close eye on it. The north-south horizontal deformation chart is showing that the ground is slightly moving towards the north, while the east-west horizontal deformation chart is not showing too much of a change. For the vertical deformation chart right here, we see a total of 0.45 meters from bottom to top. So that is it right now for Yellowstone. If you wish to see some additional analysis on activity for Yellowstone during the month of October, then please go to my website and go to my Seismo blog. I have some additional posts there about October activity. The link to my website is below in the description box. Here we are at the Long Valley Supervolcanic Complex. I don't know if you could see it well enough because of the screen capture program I'm using isn't too great, but you can see here is the Caldera imprint right here. Notice, and keep this in mind, that the earthquakes are occurring on the southwest edge of Long Valley Caldera. Just keep that in mind. So, as you can see, let me put this over here real quick. There have been 349 earthquakes at Long Valley Caldera for the whole month of October, which is actually slightly less than the total for September, last month. I believe last month, September's total was 409, I think, and this is 349, so it's slightly less. Now let's pan over real quick, right here. The majority of the events occurred at the center of the caldera, right here, stretching and spreading out like a fan towards the southwest. You notice that? It almost fans out. Look at that. So yeah, it fans towards the southwest, which coincidentally is basically the same way the ground is moving. The ground within Long Valley Caldera, as shown on the deformation charts in just a minute, is slowly inflating, going upwards towards the southwest, which is where we see the majority of earthquakes occurring, right on the deformation front. A few more earthquakes also spread out towards the southeast, towards Bishop, California, right down here. This volcano is part of my seismic image archive on my website. The link for my website is below in the description box, right under my email address if you wish to see the helicopters for Long Valley for October 2018, and other past months as well. The largest events for Long Valley for October were, let's pan this over, were 3 magnitude 2.3 earthquakes. As usual, when dealing with multiple same magnitude earthquakes in regards to the largest event, we will pick the most recent. That would be a magnitude 2.3 earthquake at 3.6 kilometers in depth on October 8, 2018 at 1940 UTC. For your convenience, here are the seismogram spectrogram spectral plots for the most recent largest earthquake to occur at Long Valley supervolcano within the month of October. When using the spectrogram and spectral plots, you can obviously see dominant frequencies between 5 and 15 hertz. You notice that right here to right about here. I'm going to say about 5 to 16 hertz actually, and you can see that on here as well. Now I bet the frequencies even surpass 30 hertz because this went well beyond 25 hertz. And it looks like the frequencies are pretty much all over the place. Also, please note the length of time for this earthquake from start to finish was about 20 seconds or so. The station I gathered this data from is NC MCV-EHZ. Here we are at the Long Valley GPS deformation charts. Let's check them out real quick. P639. Here we are. We have the deformation charts for Long Valley Caldera. Looking at the vertical chart for station P639, it seems... Oh, no, we got to move this over a little bit. There we go. Okay. It seems uplift has been almost constant since this chart started back in December 2013. It is likely this will continue and more swarms could break out at any time. Now, it is my opinion, due to the sheer amount of magma at such a shallow depth, that the constant uplift is obviously being caused by increased magma supply to the main reservoir or chamber. You notice there were actually a few dips in subsidence, but overall, uplift has been occurring. Not too great, but it's still occurring. Now, this, of course, will eventually lead to an eruption if it does not subside. When? I don't know. Uplift, again, has not been too extreme, but is enough to warrant close attention over the next few years if it does not stop. As of the most recent data, it seems inflation is still continuing. As we see on the north-south horizontal chart, there has been some interesting activity, but the most recent data suggests the ground is continuing the same pattern. There are some weird spikes going both north and south, but it does seem the pattern is continuing. Southwest-oriented inflation. That means the ground is moving upwards towards the southwest. For the vertical deformation chart, we see 0.08 meters from top to bottom. So again, it's not too much. At least not yet. Remember, magma has a mind of its own, and volcanoes can change unexpectedly in the blink of an eye, sometimes without warning. That is why volcanic seismology is of the utmost importance to me. Now let's go back real quick. Go to CA99, which is right here. We just showed this one. Let's go to CA99 real quick. Here's the deformation chart for CA99, which resides just southwest of P639. Now this is what you have to watch out for. Notice how when I click back and go to P639 right here, notice that this chart starts in December 2013. Remember that. December 2013 is when this chart started. Well, let's go back and go to CA99. Look when this chart started. Let's see. 2001. Remember, the smaller the time frame, the more detail you will see, and vice versa. And that does not just go for seismic web recorders, guys. That goes for uplift charts too. If you keep the size of a chart the same, but increase the amount of time in that chart, it will show less and less detail. For example, a 12-hour period on this size chart will show more detail than a 48-hour period. Know what I mean? It looks like uplift is pretty consistent here as well. Appears to have started around late 2011, took a quick dip at the start of 2013 right here, and has pretty much been rising ever since. However, the most recent data suggests horizontal deformation patterns remain the same, but the vertical chart has been showing some recent spikes in subsidence recently. Notice that right there. We will see in the next update where this is heading. The vertical chart, from top to bottom, is only 0.16 meters. Yellowstone still is seeing higher deformation counts than Long Valley is, but it is my personal theory Long Valley is closer to an eruption than Yellowstone is. Please don't bite my head off. It is just a theory. Remember, without theories and speculations, we would not have science. I mean, that's literally what science is made up of, guys. That's why I can't stand it when some people say, oh, you can't speculate on what that seismic signal looks like. Yeah, you can. You're supposed to. You're supposed to speculate. Like, how will people learn then? So, let's just go down. Let's go to RDOM, which is basically in the center of the caldera, right here. Again, here's the vertical deformation chart, the north-south deformation chart, the east-west horizontal deformation chart. Remember, top two are always horizontal. The bottom one is upwards, also known as vertical, which can detect inflation and deflation. Uplift recorded by this instrument actually seems to have stalled. Do you notice that right there? At least for the moment. Multiple instruments, however, do confirm that it is likely vertical southwest or upward southwest deformation will continue. Of course, that could change, but if increased deformation continues and large swarms occur on the deformation front, which would be the south-southwest edge of Long Valley, it is a good idea to monitor the situation closely. Long Valley is a very potentially hazardous supervolcano. The last eruption, called Bishop Tuff, supposedly 760,000 years ago, was considered to be a super eruption. Not saying that'll happen again this year, guys, but the whole area, even outside the perimeter of Long Valley Caldera, is very volcanic. You'd be surprised. Mount St Helens erupted 0.29 cubic miles of ash, and even rained ash in Denver, Colorado, while the ash plumes circled the world. If 0.29 cubic miles can do that, then what can 140 cubic miles or even 240 cubic miles do? Now, please monitor this volcano, protect your family, and be prepared. God does not give us the spirit of fear, but of power, love, and of a sound mind. What happens, happens, and there's nothing we can do to stop the power of volcanoes, even if we think we can. In regards to the vertical deformation chart here, from bottom to top, we see a total of 0.12 meters. Here we are at Newberry Caldera in Oregon. Let me real quick switch this. You can see the earthquake right there, just to the northeast of the caldera. Let me switch it to terrain so you can see it a little better. Okay, here are the earthquakes that have been reported for the Newberry Caldera area. Only one lonely earthquake right here was reported for this area for October 2018. September also saw only one reported earthquake. I'll monitor this area daily as well, and it is likely there were no more than 2 earthquakes for the month of October. Seriously, seismicity has been extremely low, which of course could change in the blink of an eye, so don't put too much stock to it. If you wish to see the seismic image archives for Newberry Caldera, then please visit my website. The link is below in the description box under my email address. The largest and only earthquake event that was reported was a magnitude 0.7 earthquake at 0.7 kilometers in depth just northeast of the caldera on October 29, 2018 at 129 UTC. For your convenience, here are the seismogram spectrogram spectral plots for the largest and only earthquake to occur at Newberry Caldera in Oregon within the month of October. The strongest frequencies were recorded between 4 Hz and 15 Hz. These plots were generated from the CIHL station in the CC network, which was the closest station I could find to this event. It is basically only a couple miles from the epicenter. Also note this earthquake was small and only lasted 15 seconds or so. Here we are at the GPS deformation charts for Newberry Caldera. Let's click CPCO, which is right in the middle of the volcano. The yellow line is vertical, in other words, uplift subsidence. Remember, this is a different type of GPS chart, guys. Blue is east-west, and green is north-south. You can see that right here. Uplift has been virtually negligible, except for a spike between 2014 and 2015. You can see other small spikes, including one spike in subsidence just after 2018 began, and another slightly larger spike in uplift occurring just a few months ago, but it seems like it has leveled off a little bit. Sadly, it seems the data stream from this instrument is ending. We should see it going all the way to right here, but it's not. I hope they do not take down this instrument. We need GPS instruments here at Newberry just in case. By the way, speaking of this large spike right here, let's check the closest GPS station to this one, Norm. Check this out, guys. Let's go to Norm, which is just north, just a little bit, still within the Caldera boundary. Here we are at the Seismic GPS station Norm, just northwest about a mile or so of CPCO. The only change that we can see obviously occurred at about the same time as the spike in uplift that we saw in the previous graph between 2014 and 2015. However, this time it is showing subsidence and says that it dipped to 10,000 meters below ground. That is impossible, since that would be about 32,000 feet, the height an international flight flies at. Yeah, it has to be a mistake, otherwise the other graph that I showed would have showed the same dip. However, it is interesting this mistake occurred right when the other stations saw an interesting spike in uplift. Very, very weird. However, recently, uplift subsidence has remained at normal or below levels, and same goes for seismicity. Please, though, remember that can change very, very quickly. It seems the data stream from this instrument could be ending as well. Let's pray that if so, they will put in new GPS instruments immediately. Now, let's move on to Mount Rainier. Now here we are at one of the most infamous Pacific Northwest volcanoes, Mount Rainier, which adds a beautiful but potentially deadly backdrop to the Seattle skyline. This is also a volcano that is part of my custom seismic image archive within my website. Just go to the website link in the description box below that resides below my email address. It's always being added to, and I just recently added Mount Hood to the archive list too. There have been 23 earthquakes for Mount Rainier within the month of October 2018, which is lower than last month's total for September. You can see most of them did occur beneath the summit, with just a few off towards the west. And let me just turn on terrain real quick. Let me press terrain. And there's Mount Rainier. Yep, most of them occurred just directly beneath the summit. It seems that there was no swarming this month, and that glacier tremors and ice quakes have somewhat subsided. Again, most of the earthquakes occurred directly beneath the summit, with a few scattered beyond the base towards the west. The largest earthquake occurred on October 12, 2018 at 3:11 UTC and was a magnitude 1.5 earthquake at 4.2 kilometers in depth. Seismicity remains at background levels for now. However, please remember that could change in the blink of an eye, as always. For your convenience, here are the seismogram spectrogram spectral plots for the largest earthquake to occur at Mount Rainier stratovolcano within the month of October. It is interesting to note that the frequency range seems almost consistent from 1 Hz all the way to 25 Hz. You see that? Even look at the spectrogram. It looks very uniform. But it appears frequencies below 5 Hz were just slightly stronger. This looks, though, like a typical high-frequency VT, volcano tectonic earthquake, and this earthquake lasted just about 15 seconds or so. Here we are at the GPS deformation instruments for Mount Rainier. Let's start with MUIR. So, sadly, at Mount Rainier, they really need to add some new instruments. There are only 2 GPS deformation instruments at Mount Rainier capable of monitoring the volcano for inflation, also called uplift. They are both on the eastern slope of Rainier, about halfway between the base and the summit. The first one here, MUIR, is south of the other one I will show in just a second. For the record, I hate these multicolored charts. I really hope that they switch to the blue chart since they are easier to read. Again, when seeing this type of GPS deformation chart, yellow is vertical, uplift subsidence, blue is east-west, horizontal deformation, and green is north-south, horizontal deformation. It seems uplift and subsidence has been virtually negligible, with overall subsidence barely occurring. Notice that? Last update, we noticed that there is a small spike in uplift. And I said we would see where it goes. Well, it seems the spike grew in stature. It's nothing major, but it definitely seems like a small amount of uplift is occurring, but appears to be starting to subside, hopefully. It is too early to tell which way this will go. Remember, This chart runs on 2-year intervals. This is 2018 right here. The middle part that is not marked is 2017, right in the middle. This is 2016, 2015, 2014. You get my drift. Hopefully new monitors are added soon, both to the western and southern slopes of Rainier. It seems from about November 2012 to January 2013, which is right about here, this monitor had a significant change in direction, about 0.12 meters, within a very short period of time towards the northeast, with barely any change in the vertical uplift subsidence pattern, with just a slight bump right when this occurred. Let's go back real quick and go to CSHR, which is north of MUIR. Wow! What a complete disappointment. This monitor, CSHR, the only other GPS station actually on Mount Rainier slope, has been discontinued since about October 2014. God knows why. Please ask USGS and PNSN to add some more deformation instruments around the slope of this volcano. I doubt that there are many other stations up here recording deformation. If there are, they're not currently available to the public. Does USGS conduct actual geophysical observations for bulges or other concerns at Mount Rainier? I sure hope so, because if I were in charge, I would definitely post at least one deformation recorder on each side of the volcano halfway between the base and the summit. I really hope a new GPS deformation network is installed soon for Mount Rainier. Seismicity and deformation remain low, except for an interesting spike and uplift just in the past couple months, which obviously you can't see on here because this one's not working very well. We will have to watch that closely and see where it leads, and another update will be issued for the month of November after the month is ended. Of course, if any major changes occur, I will obviously update you via my blog, on my website, and my YouTube channel. And here we are at the volcano that gave my mother a very bad day on May 18th, 1980, Mount St Helens. This volcano pummeled my mother's house with inches of ash and even rained ash on my dad's car in Denver, Colorado. The main Mount St Helens eruption ejected 0.29 cubic miles of ash, compared to the possible 140 or even 240 cubic miles Long Valley could possibly eject during its next coming eruption. When will it erupt? Who knows? But let's just take a look at this real quick. You can see the earthquakes here. It seems about half of them occurred under the summit. And let's change this from grayscale to terrain, just so you can see. There we go. Now you can see Mount St. Helens. Let me move this over just real quick. There have only been 35 reported earthquakes at Mount St. Helens for October 2018, which is actually slightly higher than last month's earthquake totals. It does seem, though, that half the events took place beneath the summit, right here, with some other small earthquakes scattered around the base of the volcano to the northwest and towards the northeast, with a few towards the west. Now, real quick, before I show the largest event of the month, I want to point your attention to this, right here, this little dot right here. Notice it is very peculiar. It says this quote-unquote other event was a magnitude negative 0.5 event at negative 1.7 kilometers in depth, showing it most likely occurred at the surface at 0:30 UTC on October 23, 2018. Now, they never report rock falls or avalanches, so the fact that they labeled this as quote-unquote other event is very odd to me. Here are the seismogram, spectrogram, spectral plots of this strange unknown event. All indications on all three plots do seem to indicate some type of rock fall event. However, since station HSR, the station I used to generate these plots, is extremely close to this event, we should see a much higher amplitude than just what? 150, 200? I think it went to about 200 amplitude count. But we don't. Please note the amplitude count on the seismogram plot. Again, remember to always read chart labels, guys. Always read chart labels first. Always, no matter what you're looking at. Another weird thing is that if this was a rock fall, USGS would have had no reason to label this as a quote-unquote other event. They just would not have reported it, because there's no point in reporting rock falls, guys. Note the dominant frequencies are between 2 Hertz, notice that, all the way to 15 to 16 Hertz. This really does look like some type of avalanche or rock fall, but then why did they report it as quote-unquote other event? Very weird. Now, the 2 largest quakes to occur within this time period for this area are the same size. Usually I would use the most recent, but the most recent one is far beyond the base of Mount St. Helens right there. So I'm just going to use this one right here. The largest reported quake for Mount St. Helens itself was a magnitude 1.0 and 9.9 kilometers in depth at 1405 UTC on October 22nd, 2018. For your convenience, here are the seismogram spectrogram spectral plots of the largest earthquake to occur at Mount St. Helens stratovolcano for the month of October 2018. Dominant frequencies seem almost equal from 5 Hz all the way to about 20 Hz, but obvious spikes can be seen at 8, 9, and I'm going to say 17 Hz. For the record, this earthquake was preceded by a very short-lived low-frequency vibration, which I think was a low-frequency harmonic tremor at Mount St. Helens. Since this was deep, this could have been near the magma chamber, so this could be associated with some type of magma movement. It still is going to be considered a high-frequency VT, volcano-tectonic earthquake. Now, that's just a possible theory. Don't bite my head off. This earthquake lasted about 21 seconds or so. Here are the GPS deformation instruments for Mount St. Helens. Let's pick P697. Sadly, there are no GPS instruments available to the public for the actual dome itself within the St. Helens crater. I picked P697, which I feel is the closest to the dome, but resides on the southeast rim of the summit. It seems the data stream from this instrument stopped gathering data around January 2018. Hopefully they do fix it. Again, yellow is vertical, blue is east-west, and green is north-south. It currently seems to be moving northwest slightly, with uplift spikes being seen at the beginning of each year, it seems. No signs of renewed substantial dome growth as of yet, and it appears St. Helens is still within background levels. But some weirdness has been occurring lately. However, as with any volcano, that could change very quickly, especially with Mount St. Helens, guys. Magma likes to be independent and for sure has a mind of its own, regardless of the type of magma the chamber houses. The recent Kilauea eruptions are a testament to that fact. Now let's just look at a few more real quick. Wow, they don't have that one. Oh well. Okay. That's very weird. They need some, they really need some new instruments. Look, they all end. Oh, this one's still working, but most of them are just down for the count, sadly. And of course, there are none for the dome itself, which I don't know why they don't just put one on the dome. Oh well. Here we are at the Mount Hood volcano in northern Oregon, which straddles the border between Washington and Oregon. There have been 5 reported earthquakes at Mount Hood for the month of October 2018, which occurred on the southern portion of the volcano. Let me turn on terrain real quick, just so you can see the location a little better. It occurred on the southern slope. 1 occurred directly beneath the summit, 1 slightly closer or slightly farther away than the summit, 1 near the base, and 1 beyond the base. But they all occurred on the southern half of the volcano. The largest earthquake was a magnitude 1.6 at 2.7 kilometers in depth, occurring on October 25th, 2018 at 7:59 UTC. Seismicity seems to remain at low levels, but is slightly higher this month than last month, so we will keep a close eye on this. For your convenience, here are the seismogram spectrogram spectral plots for the largest earthquake to occur at Mount Hood stratovolcano within the month of October. You can clearly see dominant frequencies below 16 Hz, with a spike at about 9 Hz right here. However, the 2 closest stations to this event were offline during this time period, so I had to use the 3rd closest station, VLL, which is 10 miles or so north. So the waveforms and frequencies might be slightly diminished, since it was a distant station. Here we are at the GPS deformation instruments for Mount Hood. Sadly, once again, it seems GPS deformation monitoring at this volcano is not as great as it should be. Let's do P791 real quick. Lovely. Only 2 instruments reside on Mount Hood, and they're at the southern base. It seems instrument P791 is useless since it stopped working in the summer of 2016, so that leaves us with the only other GPS deformation instrument available, MHTL, which we will go to that right now. Even though this station resides just west of the station I just showed on the southern base of Mount Hood, it still can give us good data since it still seems to be in working condition. However, it looks like deformation is basically negligible with 2 spikes in subsidence, which is also called deflation, after the start of 2010, which is right about here, and after the start of this year, 2018, which is right here. Since this chart began in 2007, the ground has been slightly moving northeast, though at a very slow rate. Deformation and seismicity at Mount Hood remains at low levels, at least for now. However, now it seems there is a small spike in uplift starting. You see that? We will see where this is heading, and we'll update you about this in the November 2018 Volcano Update, which will probably be uploaded around December 4th or December 5th. However, it does look like the slight uplift sequence could be short-lived. It looks like it's starting to go back down now, but it's too early to tell. We'll see. Remember, you don't have to wait for my next update, guys. You can monitor this stuff yourself, too. Here is October 2018 seismicity for Mount Shasta. You see one earthquake right down there. And let's just turn on the terrain so you can see where the volcano is. There's Mount Shasta, there's the earthquake. Mount Shasta resides just south of the California-Oregon border. Also, if you have ever driven from southern Oregon into California using Interstate 5, you already know the volcano is very ominous. There was only one earthquake reported for Mount Shasta during the month of October. It was a magnitude 0.6 at 3.0 kilometers in depth on October 31st, 2018 at 3:28 UTC. It occurred about 12 miles or so southeast of Shasta summit. For your convenience, here are the seismogram spectrogram spectral plots for the largest and only earthquake to occur at Mount Shasta stratovolcano for the month of October. Notice stronger frequencies occur below 10 Hertz. Notice that? But frequencies do reach all the way to 20 Hertz though. This was a very small earthquake. Notice it's from here to right about here. Very small, barely even noticeable. And the thing that's funny is that since this earthquake was very small, this station, LMC, is the station that was closest to this event, but it barely even showed it. They really need some better seismic stations out here, guys. They really do at Mount Shasta. This earthquake lasted a total of about 7 seconds or so. Here are the GPS deformation instruments for Mount Shasta. As you can see, P657, let's pick that one. I like these charts way better than the multicolored charts. Once again, there are no GPS instruments available to the public on the actual volcano itself. There is, however, multiple GPS instruments around the base that quite possibly could detect new influx of magma within a deeper region. However, shallow deformation on the summit, a sign an eruption could be approaching, most likely would not be seen except with human observation. However, just like other stratovolcanoes, seismicity would almost certainly increase prior to an eruption. So at least we have that. It seems deformation and seismicity at Mount Shasta remains at low levels. The vertical chart, which we see, records uplift subsidence. We see a total of 0.07 meters from bottom to top. Here we are at Lassen Peak, the last volcano in the update. Again, Glacier Peak in Washington State will be added to the update once new instruments are installed. But here's Lassen Peak, which is a volcano in Northern California just 60 miles southeast of Mount Shasta. You can see most of the earthquakes occurred in the southern half of the volcano. Here, let me turn on terrain once again so you can see where the volcano is. 2 extra earthquakes occurred down here, and most of them occurred on the southern half of Lassen Peak. Let me move this over. So there are a total of 15 earthquakes that were reported for Lassen Peak for October 2018, which is slightly higher than last month's totals. The seismicity appears to have occurred on, again, the southern half of the volcano, with a couple of earthquakes actually registering at a negative magnitude. Look at this real quick. Look at this. Okay, let's see, what was it? Negative 0.0, negative 0.0, negative 0.1, negative 0.1, negative 0.2, negative 0.2. Look at that. That is so weird, all negatives pretty much. Now, the largest event was a magnitude 1.1 earthquake at 8.1 kilometers in depth on October 11th, 2018 at 2:02 UTC, which actually occurred, let me show you real quick, occurred a few miles beyond the perimeter of this volcano, but it's still within the perimeter square that I set for the earthquake catalog, so it still could be related to Lassen Peak. For your convenience, here are the seismogram spectrogram spectral plots for the largest earthquake to occur at Lassen Peak for the month of October. You can clearly see an unreported earthquake right here, which happened right before the main 1.1 earthquake here. This is the 1.1, guys, right here. This is not. This is definitely an unreported earthquake. The main 1.1 earthquake had frequencies reaching beyond 20 Hertz, but the most powerful frequencies were occurring 15 Hertz and below. Mostly between 5 Hertz and 15 Hertz were the strongest frequencies. Also, this earthquake lasted about 18 seconds or so, with this one probably only lasting about, what, 5 seconds maybe? Here we are at the GPS instruments for Lassen Volcanic Center for Lassen Peak. Let's pick P666. Trust me, I would have picked a better name for this instrument. On a more serious note, it seems Lassen Peak is well set with GPS instruments, even though they're more towards the southern section of the volcano. I don't know why. Though it seems those instruments do go out once in a while. So it seems P666 is showing multiple spikes of southeast-oriented uplift. That is, the ground moved upwards in a southeastern direction. Notice that. Horizontal east-west, going east. Horizontal north-south, you can tell these are going south. And here is uplift. You can see uplift is upwards, subsidence is downwards. You can tell these spikes do coincide perfectly with one another, showing 4 distinct events. You can see them right there, with each of the 4 events moving the same direction as the last. Upward southeast movement with what seems to be each deformation event being larger than the last. The 4 deformation events at Lassen Peak moving upwards towards the southeast occurred about April 2014, January 2015, March 2016, and February to March 2017. It seems it was moving in a pattern, but skipped 2018 for some reason. We should have seen it right here where you see a little bit of these quote-unquote bubbles coming up. We should have seen another one here, but it didn't work out. Of course, we would keep monthly tabs on these areas I just talked about, and I would not be surprised if southeast uplift at Lassen Peak occurred around December 2018 this year to about March 2019. If so, be wary of swarms occurring on the deformation front, occurring at Lassen Peak from the summit to beyond the base from south to southeast. It seems around October 2017, uplift slightly increased and then decreased around April 2018. Looking at the most recent data, it seems to be slowly rising again, so we will keep a close eye on this as well. However, it is unlikely Lassen will erupt soon, since its last major eruption was in 1915. But you never know. And yes, they actually have pictures of some of the eruptions you want to see. Here are some pictures of the 1915 Lassen Peak eruption. Let's see. I think this is another one as well. This is one of the famous ones right there. You can definitely see it's erupting pretty good. Almost looks like Mount St Helens a little bit. Here's one of the more famous images right here, showing it off in the distance. That has nothing to do with Lassen Peak. I don't know why that's on there. That has nothing to do with it either. Here's another famous picture of Lassen Peak, May 22nd, 1915. Yes, guys, they did have cameras back then. Here's another picture of Lassen Peak, but way after its eruption. It says, I think it's 1977 this picture was taken. Here's an aerial view of Lassen Peak and the surrounding area. And I'm not seeing many other pictures. They didn't have too many pictures of the eruption, but it's very, very interesting, that's for sure, that they even had pictures of this. And after the Lassen Peak 1915 eruption, all the volcanoes in the Cascade Range in the whole continental United States went quiet. No eruptions from 1915 to 1980. Once 1980 hit, though, Mount St. Helens erupted. And here we are back at the wonderful Upper Geyser Basin, home to the infamous Old Faithful Geyser. Well, it seems Yellowstone and Long Valley supervolcanoes have the highest seismicity counts out of all the volcanoes I showed for the month of October 2018. That figures. Of course, concerning activity at any of these volcanoes will warrant its own video and its own blog post on my website, especially if increased deformation is spotted in conjunction with increased seismicity, almost a sure sign a magma chamber is growing restless for an approaching eruption. For those who watch my videos, please go check out my website. My website is helpful in conjunction with my YouTube videos. I will also be able to upload more information on there than if I was only making YouTube videos. So if you like, please go check it out. It's got some interesting information, you'd be surprised. This is the 4th monthly volcano update I have put out. The next monthly update will be issued for November 2018, which will be uploaded a few days after the month has ended. Please visit my recent videos on my channel, which include recent updates. The homepage on my channel seems to not work very much, so just go to my channel and just press videos. Maybe I have to set up the homepage? Because whenever I go to other people's YouTube channels, it's on the homepage, and, you see videos. Sometimes you see a title video, but mine just says nothing. It says there's no videos at all. But then you click videos, and you can obviously see videos. I hope to someday become educated in regards to volcanoes and earthquakes and hope to become a volcanic seismologist. Any support would be amazing. And no, I'm not talking about money. I'm talking about personal support from my viewers. Thank you all, and keep your heads up, and please be prepared with, at the very least, 3 days of food and water per person within your household. And I said at the very least, guys. That's the least. That's the minimum. Please double that per child that you have under the age of 12, just in case. The more food, the more water, the better. And don't tell anybody about your secret stash of food and water, guys, because if something happens, guess who all the people are going to come to? You. If any mistakes have occurred or I am wrong about something, please feel free to let me know below. I am a chill guy that is actually okay with constructive criticism. Sadly, the world, and especially YouTube, has way too big of an ego right now to think constructive criticism is actually a good thing. Even though that's really how we learn, guys. Being wrong is how we learn. If you think you can never be wrong, you're never going to learn, and you're going to end up making a fool of yourself. And a lot of YouTubers have done that. I will always stand for the truth, no matter where it leads. Why? Because the truth is considered hate or fear to those who hate or fear the truth. God bless, and Ben Ferraiuolo signing off. See you later, guys.